All right. Yeah, thank you everybody for coming out today. It's a good sized crowd. Me and Bryce came by yesterday to look at the rooms and get an idea of how everything was set up, and they were still divided then. So we were thinking, this room's tiny, this is awesome, this will be no problem at all, but it's definitely a healthy crowd this morning. We appreciate you guys coming out. So our talk, like you said, is Splunking Dark Tools, a Pentester's Guide to Pwnage Visualization. I'm Nathan Bates, and this is Bryce Kunz.
Hey, so I'm Bryce. I run the red team for Adobe's digital marketing business unit, and we do a lot of offensive testing against cloud infrastructure and Linux servers. You know, that's kind of what most cloud infrastructure looks like. Prior to that, I worked in the Department of Defense doing offensive work, and prior to that, I worked at the Department of Homeland Security doing security monitoring and incident response. So I've kind of made the loop. So. And
I'm Nathan. I'm a security engineer that focuses primarily on blue team technologies, monitoring response, just defense. In the room, I don't know, maybe people will raise hands. As far as people who are primarily team. Is there anybody in here who's red team? We've got Bryce. There's a handful. A blue team? All right. There we go. Me and Bryce had a bet on this actually, but anyway. In this picture, I'm usually the one getting hit. So all us blue team guys, I think we understand it's hard, it's difficult, and there's always moving infrastructure and things are tough.
So, executives, they got a lot of important decisions to make. Raise a hand, who here's in a management role? Yeah, me too, right? So, yeah, so it's, you know, and the thing that executives love most is they love the latest and greatest. They love the AI, the MLs, the IoTs, the augmented reality, the virtual realities. They got to pivot the company. They got to, you know, they got to make it in the valley, right? So they got a lot of important decisions to make, and you know, really, a lot of these tech companies, they're concentrating on acquiring new technologies and then integrating it with their existing operations. And so, you know, the execs, they acquire some company that has some new technologies that they want to roll in, and then everybody's happy, right? All the execs are happy. They're high-fiving each other. They're having a great day.
When that happens, there's a whole lot of new infrastructure and not a lot of time to look at it. That attack surface increases with every big acquisition, with every new product, with everything that's rolled out. And there's a lot of responsibilities that end up falling back to the red teams and blue teams for figuring out what's going on. A lot of times, you know, it can be thousands of servers within, you're supposed to look at them within, you know, a week or 2 weeks, which any of those red team guys out there realize that's nearly impossible. You can't give anything enough attention and energy to really get the information that you want out of it. And when you do find those things, these new acquisitions, they already have their culture, they already have their stack, their technology, and a lot of times they're a little bit stubborn. They don't want to change. They wanted to get acquired, they wanted to, you know, cash out, get money, whatever, but they don't necessarily always want to work on the security stuff. So sometimes you need that extra information to help them move, and that's where these big pen tests and the big results from all of the data comes together.
So, oftentimes in a situation, right, where you have various groups disputing about, you know, whether their security posture is adequate or not, right, it makes sense to have kind of a third-party group come through and independently assess the security posture, find those risks that they can find within the infrastructure, and then prioritize them to get those fixed. I mean, really, you know, you can say your systems are secure all day long. I mean, it doesn't mean much if a red team can roll in 24 hours, pwn the entire thing, right? So really the red team in this situation is really kind of looking as like a group that's coming in and helping you assess the risks that are there, and determining, do these new acquisitions really need to go through and do a bunch of changes, or are they pretty secure as is? So, imagine your boss comes to you and he says, hey, we just bought this thing, they've got 10,000 servers on the internet, and we need you to go through and figure out what's wrong with it. And by the way, I need an accurate description by Friday, right? So as a red teamer, I don't really have a lot of resources. It's a very small team, and things can get quite chaotic quite quickly. A lot of the latest bleeding edge tools and techniques that are coming out of this conference are really designed of standalone proof of concepts, right? I don't know if you guys have been engaged in using pen testing tools in the past, but a lot of them they give output back to standard out. Maybe sometimes they'll get a CSV file or an XML file or something like that as part of the output, but a lot of times that they lack any sort of normalized way to do integration as a whole. And a lot of pen testing tools, in my opinion, are unnecessarily hard, right? They're designed for a specific purpose, but the switches that you have to use with them and the arguments that you need to use with them, you have to memorize these or have these in some wiki system, knowledge management system that you can look it up quickly. And if you're trying to scale up, like you want to have Nathan come jump on the red team and help me out because I got to get this job done by Friday, it's hard to train people up really quickly without I don't know if you guys have seen those pen testing cheat sheets that are out there, but that's really trying to solve this problem of memorization of all the complex commands and tools. And then, it doesn't really scale well, right? Like I can SSH to a bunch of boxes and run commands, but that's not really an effective scaling solution if you need to, test more servers quickly. So we wanted to do something about this problem. We wanted to do it better and different than the way it's been done in the past. And so, we created what we call dark tools. And pirate skeletons, they agree. Dark tools, it's easy and scalable. So we're going to demo this for you now so you can kind of get a better concept of what dark tools is and how it solves these problems. All right, so everything related to dark tools leverages Docker, right? So you do have to have Docker installed as the dependency, and then you're good to go. Everything else is contained inside those Docker containers. So when we run this script, it's just starting up a Docker container, and it's dropping us into this Metasploit-like console. And another key component is everything related to dark tools is project related, so that you and your team can work multiple projects at the same time. So here you can see the first project is called Dino Eagle, and I just have a single selector associated with it, this root domain, Dino Eagle. And with the demos today, we're kind of taking the assumption that most of the things that would resolve under the root domain are going to be in scope for the testing, right? As it would when you acquire a new company. There is some ways, as we look under the hood, that you can blacklist IPs you don't want to touch and different resources like that, but we'll get more into that as we go. So you can list out the projects, you can add selectors to projects, you can, basically interact as you would through a normal Metasploit-like console. And I built out this workflow called autopilot. It's very easy to use, right? So we add the selectors to the project, and then we autopilot the project name. And then once you launch that, you're pretty much good to go. From there, your data is now going to start flowing into Splunk in real time as these microservices start to collect data from the target network. They're going to send that data into Splunk, and we've developed a Splunk application that's going to visualize this data for you. So it's kind of two ends, and we'll get more into under the hood how it works. The framework that kind of you're controlling and kicking off the automated pen testing, and then the Splunk app where it's taking and visualizing the data to make it easy to view. And so, you know, the dashboards, they have like, this first dashboard just has all the selectors it was able to find through open source intelligence. It has what TCP ports it was able to identify were open against the target, and then which microservices sent data in about which TCP ports. It's trying to give you a general overview of what the infrastructure looks like. And, you know, it does common tasks that you've seen before, like subdomain discovery, geolocation inside of the application, so you can see where the data centers are physically located. And it's generally trying to make your life as easy as possible to take care of a lot of those mundane tasks that you have to do when you're trying to test a large spread of servers quickly. We try to do some trending, so if you scan multiple times, you can kind of see if servers are going up or down. And then we also do like service enumeration, even like on this particular target, we're able to find some web resources available publicly. We're also able to discover that the SSH service daemon is running on port 8080, so a non-standard high port, right? Oh, well, there goes the demo. So another key component is we're giving weighted risk. Well, that was great.
All right, PowerPoint.
All right. Good job, PowerPoint. So I appreciate that. So there's a weighted risk inside of the console associated with based off the data that's coming into Splunk, which basically says like this is the servers that we think you should look at first based off of different components of the data that's coming in. So that demo kind of crashed. I don't know what happened there. But we're kind of visualizing the data, and now we're going to drive more into how that works under the hood and how you guys can set it up for yourself.
Definitely. All of the data coming from the apps, it gets delivered, and everything that we're doing within these tools is just about having actionable items. If it's not actionable, like we can't do a lot with it, so the goal is really to improve that data, to create a process around it, to make it consistent so that we can get stuff done, so that systems get better, so that there's more Pwnage on those new groups, and we can get roadmaps out of that. So that starts with the automation in the system. A lot of it, when the new systems are enrolled, going directly through autopilot, it breaks it out, it finds everything, it finds new domains, it finds all the IPs, it starts linking things together, and it puts this on scheduled attacks. So if things do change over, days, hours, there's new services, it's something within your customers or your projects, your teams that you're going to be able to catch. And it puts it in one location. The data consolidation is huge. It's all of the tools in one place where they can be used together is where we end up getting a lot of the better results and finding the attack vectors that are definitely more severe. And that leads directly into the visualization. When you have 10,000 servers, 15,000 servers, you're scanning all of them, trying to understand those specific parts of the pen test. It's just for extracting data. It's to find the outliers, because the outliers are usually where the bad remote code execution or vulnerabilities are. And that's it just needs to be consumable after that. So that circle, it just kind of continues. We constantly pull out the actionable data. We try and feed back into the system. And it needs to be put in that place where you can collaborate with each other, with groups, with larger red teams where you're dividing up 10, 15 separate projects with 500, 1,000 servers each or something like that. It can get chaotic. And that's just during the assessment. Once the assessment's over, they need to share the data. They need to tie it in with other resources for the blue team data and to make reports or the information available for management so we can actually get things moved and buy off for all of those types of items. Like I said, the visualization, it really is there just to find the most severe items, the higher risks, and so we can action those first. Right now, it's not going to own the systems for you. You still need to kind of understand how to use the tools. And in the main case, it's to speed it up and just to make the process go smoother.
Okay, great. Thanks, Nathan. So now we're going to be looking a little bit more at how the framework works under the hood. So it's highly reliant upon Docker. So the servers or infrastructure or VMs that you're running on top of need to support Docker. I built out some install scripts for common operating systems, even though it's not hard to get up and running. So if you want to, you can just run those. It should install Docker. And then the components and microservices just run inside those Docker containers. And basically, the console that you saw in the first demo, when you start that up, it connects out to the message queuing system. And everything, all the microservices coordinate through this message queuing system. And so I'll just kind of walk you through the logic and workflow is, you say, hey, autopilot, start on this project. We have this root domain here, and we want to go find interesting stuff there, right? So then a microservice picks that request off the queue and just says, all right, I'm going to go find all the subdomains. And so each microservice could consist of some custom Python code that I've written, or it could also reach out and try and use some tools that we all know and love, like the find subdomains microservice. It reaches out and it does leverage like GoBuster and a couple other tools on the back end to help find domains and ensure you're getting the coverage that you need. And then once it finds new subdomains, it shoves those back into the message queuing system. And then you have another microservice that's resolving IPs and kind of building out these objects that kind of have the domains resolving to the IPs. And then the framework via the console has a concept of a blacklist, a whitelist, and a graylist. So you can add IPs to the blacklist that you don't want to touch, and you can tag selectors white or gray, and that will determine which further modules in the framework are going to get executed against the target. So yeah, we can dive more into that. But then all this data, as the microservices are running, are sending data into Splunk. And so if you're looking inside of Splunk in the DarkTools app, you'll see data being updated in real time.
It's being delivered through a technology called HTTP event collectors. This is something that's specific to Splunk right now, but there are a lot of open source solutions that do something similar. And the gist of it is you enable the HTTP event collectors on the systems. It's not something that's done by default, but you generate specific tokens for the type of data that you're looking at, and those tokens get assigned to indexes within Splunk. The posts coming from the autopilot system for each of the modules coming from the Bandits or anything else will post directly to that receiver with that information, and then it's indexed. It's broken out like normal Splunk, key values are extracted, and everybody's happy. This is what the type of HTTP event collector messages look like. You can see it's a post request with headers that specify an authorization for Splunk and the token that's associated with the source type. After that, it's just location-based. Ours, a lot of it's running within the same test environment within AWS, but it can be distributed all over the place, however you would need it. The JSON objects within those, you can see that it's standard. It's broken up by project, domain, IP, so that those will automatically be populated within the Splunk application.
So flipping back to the framework under the hood, right? So we've kind of got a list of domains and IPs. We know which ones are in scope, like they're not on the blacklist, or they are on the whitelist. And then we're just going through and using other microservices to discover, what ports are open and what services are running on each of those ports. So everything's microservice based inside of this framework. So if you hit any bottlenecks, you just spin up more of the Docker types that have that type of microservice inside of it, and then they'll just start picking data off the queue, the message queuing system. The message queuing system is highly reliable, so it will ensure that it's not dropping messages and everything's getting worked. And then once you kind of get a targeting object blob that has the domain, the IP, a port, and protocol, the framework sends that off to the dispatcher, which is called Smokey, and Smokey sends those off to the Bandits. And really the Bandits is the bulk of the microservices. I've built out quite a few examples that you can use as templates to build out and expand on the framework. But each of those is going to accept this same targeting object, and then they're going to take some type of action and then send that data back into Splunk to get visualized. So when we saw in the first demo, we saw it discovered kind of those files on the web server. That was via this web find resources, kind of like Derby equivalent microservice. And then other microservices can do pretty much any type of task you would do in a pen test. You can automate that by building out a Bandit module to wrap around that.
So the next question just goes back to why Splunk. There are a lot of open source solutions out there. You can use Elk Stack, you can use, flat files, you can do it with databases. There's a lot of options. And for us, we use it already. We're fans, we use it in our other environments. Our defensive data is there. It's something that we're familiar with, and it's simple and it's scalable. It doesn't have to be complex. The systems that we've set up for all our testing were based off of simple images with CloudFormation templates. Everything came up good, and you can tie it directly into enterprise security. Enterprise security is Splunk SIM that sits on top of it, and the data that can be used within the attack data will be able to be correlated with the actual blue team and defensive data, which adds a whole other levels of just confirmation and collaboration. It's already in use. We use it. A lot of other groups use it. So it was just kind of the clear choice for us. We went back and forth on whether people need demos for this type of thing. I think most people in here can get it installed in a couple minutes. It's not a big deal. It's RPM packages or AMIs or Amazon instances. So you basically get the system set up, create the index, enable the event collectors, and then install the apps. The apps we are going to release this week. So it's something that you'll be able to pull down and use in your own sites also.
Okay, great. Thanks. So the Bandits, I built out quite a few of these Bandit modules to try and automate most of the common pen testing tasks that I have to do. And I've been trying to get ahead of the curve, right, before the next big assessment comes down the pipe, and it's got to be done quickly. But you can really build these out to do anything. They're written in Python, and as you build them out, they'll just connect into the queue and automatically dispatch tasks out to Splunk. So I wanted to kind of give you guys an example of how easy this is, right? So you'd kind of have a primary function where you'll want to automate whatever task you're doing, whether this is just writing some type of check against the server in Python or wrapping around and executing your favorite pen testing tool. And then you'll want to take that output and make sure that you can get it back into a JSON format. This is quite easy. You can see a few examples of me doing this. Reading files from disk, like XML files or CVS files, and then parsing them back to JSON. And then you just take that and you build out this JEvent JSON blob, and you use the Splunk event function that I built out. And once you call that inside of the Bandit, the data automatically gets sent out to Splunk in real time. So it's very, I hope it's easy, and if you have any questions, feel free to reach out. But I try to make it as simple as possible to get more collaboration inside of the community.
Definitely. It's actually, I think it's one of the most important parts of it, because everybody has different tool sets. They have different information that they want and different ways to look at it. So it's built to be modular. It's built to be expanding, and the data can all be used at the endpoint once it's there. And as the data is delivered, we do have to get it more delivered, or to make it more usable. There's a lot of ways to do this. It's the normal standard field extraction. This can be done before it hits Splunk, or set up so that it'll be done before it hits Splunk or after. Most of what we're doing is actually in the Python side, and it's just by tying the values together within JSON. You saw the examples of the actual post messages. This makes it a lot cleaner. It'll make it so we can tie lots of different sources together and the data is just normalized. In Splunk we can do it also, and there are instances with the app where it's definitely the only choice. And it's just normal regex at that point, and it is done per source type on each of the indexes. I'm sure anybody else who's already doing it within Splunk understands the process behind that and how important that is. To help the data out and to pull things together, we are generating specific lookup tables, because not all of the information from one scan was going to have everything you need. So it may be an IP-only scan and you don't have any ties together with the domain or with the services or ports or anything like that. So we do have asset table creation running from the lookup tables that ties the systems together, so that on the analytics pages or some of the more complex reports, everything's there and the way that it needs to be. The GeoIP data is used in quite a few reports. It's to understand location and how things are distributed within the targets. It's the GeoIPs, it's similar to any other app that's using that type of data.
Thanks. So I just wanted to kind of highlight two ways that you could set up the system, right? So the first way is you could just run all these components on your laptop or inside a VM. Like you could just use your Kali Linux VM as long as you have enough memory assigned to it, and you could stand it all up so all the microservices and MQ all run inside of that same Kali Linux VM. This is kind of what I would call like more of a development environment. In production, right? The way that that it's really designed to be used is your laptop would just run the console. The console would reach out and talk to the message queuing system, and then all the microservices would run on their own servers, maybe in some cloud provider like Azure, or maybe on physical hardware inside your data centers. And then they would orchestrate and send the data to Splunk. So it really was designed for the scenario where you're trying to scale large and trying to do distributed. The great part is, as long as you have servers that can talk back to the message queuing system and they've got resources, you can keep deploying more and more of the microservices. I'm really hoping that in a future version that we're going to be able to incorporate some auto-scaling features with the framework. So like either via, like a DCOS or Kubernetes, where it would scale up the microservices. And then, we're also looking for future versions to maybe leverage some more cloud proprietary technologies like Lambda and things like that. So, but for now, you want more, you can spin up more servers and just run the script and it'll spin up more microservices. Okay, great. So hipster skeletons agree. Yeah, it's scalable and it's easy. I want to show you guys just a slightly bigger demo. So, and I'm hoping the demos kind of help you guys get the concept. When I've used these on like real world engagement, it's usually thousands of servers. So for this demo, we're going to look at a slightly bigger environment, but not really at that scale yet. But it works the exact same way. So you list out the projects. This time we're going to look at the Dark Grifter project. We just have this new root domain we want to check out called darkgrifter.com. And we're just going to autopilot against Dark Grifter project so that it will kind of take care of all the details in the background automatically for us. And so when we do that, when we hit go on the console, it's going to send the request off to the message queuing system. The message queuing system is going to reach out to the microservices to discover subdomains, and then another microservices that resolves IPs, take care of the port scanning, service discovery for you, try to discover files on the web resources, try to do UDP scanning, and then all that data is coming back into Splunk in real time, being visualized by the Dark Tools Splunk app. So you can see all the IPs it found were here. And just in this list on the first dashboard, the domains are kind of here. If it's able to find any email addresses from OSINT, it's going to chuck them there. And then it's also going to just show you all the ports that it found open associated with this particular project. It's also going to have that same visualizations as you saw before, trying to map what data is coming from what microservices. And I kind of just wanted to highlight, I don't know how, by raise of hands, how many of you used Splunk before? Okay, most of you. Okay, awesome. All right, so no need to like belabor this point, right? But if you click on something, it jumps into the event that generated that data, and so you can select off that more, right? So dive into the events just like you would regular Splunk type queries. So it's going to try and crop up that data that we think that was most important to the users. We're mapping the microservices, breaking down microservices to the port data that's coming in here. And we're really just trying to help you understand what the infrastructure looks like to help you prioritize what should I be working on first. And so we've built this, you can see the domains per count on here. You can also see, you know, like where there's multiple domains resolving to the same IP address. That's being visualized on the left over here. Through virtual hosting or whatever. I know that's very common. You can see it checked for UDP services, so you can see SNMP is on the internet on these servers here, accessible, right, which you may or may not want. And then you know, it also finds common UDP services like NTP. That's all pretty common stuff, but this is all being visualized back in the Splunk app for you in real time. You get the mapping of ports to services, and it's really trying to help you identify targets and what you should be working on next. So correlation here between multiple subdomains going to the same IP. I think that's what it's trying to say. So cool. All right. So it did a Derby equivalent and was able to find a /logs directory that's accessible on one of the servers. It's giving on the left a weighted risk associated with that server. It's showing you, you know, which domains have what services running on them. It's really trying to help you start your investigation and what you should dig into more, or look for things like, you know, MongoDB on the internet or other things like that. And you can see the jira.darkgrifta.com web server is kind of the one that it ranked as the riskiest. And when we browse to it, we can see, okay, it's running some random web app. Not really sure what that's about. But so let's check out that logs directory. And so we can see, you know, for some reason, due to a misconfiguration of the server, the logs are being exposed to the web service. And I'm not having much luck with PowerPoint today, apparently. So the logs are being exposed through.
Gotta thank the demo gods.
Yeah. Apparently, I did not make the right sacrifices. So the logs are being exposed. So I mean, a seasoned pen tester, right, would, you know, really see there's an opportunity here. But I just wanted to kind of walk you guys through the logic, right? So he says, all right, that's cool. Let's check out the auth log, right? On Linux, auth logs, they have, you know, who logged into the box, generally via like the PAM subsystem, like SSH logins. And if you actually dig into the auth log, sometimes you can find some pretty interesting data. So here we see we're digging into the auth logs here on the remote web server that are accessible via the web that we found using the Darks Tools app. And we could see that there was an invalid login on the server for the username, super secret, do not tell my mom, right? So we see this, that looks pretty unusual, right, in the auth logs. And then right after that, we see a user named Brian. He successfully authenticates. So kind of like stepping back and thinking about this logically, right? It appears as if the user Brian attempted to log into the system with his password in the username field. That got chucked into the auth log. We pulled that out of the web server because it was misconfigured. And we may be able to access his account via the SSH daemon using that clear text password. And I know this seems very trivial, right? But I often find like it's those simple things that where users just make mistakes that really start to blow projects open, right? So we SSH into the remote target using Brian, the username, and using the password, which was inside the auth log. And using that data, that was all discovered using the Dark Tools framework and Splunk app. We are now able to, gain SSH access into the remote target. So really, we're trying to help you guys find those things that are egregious, proactively. We're trying to do this at scale so you can quickly do it. And we're trying to do it in a way that hasn't been done before so that we can really solve that problems of, repeatability and scalability.
All right. A lot of our test scenarios where we were scanning a lot of internal resources and other projects, like Bryce said, it was a few thousand servers, and it definitely the app and the services shine at larger scale. For some reason, we had a hard time getting legal to buy off on showing everybody all of the attack data for all of our internal services, which is why we have all this other demo data. But it really does, it works good, and the more data that you throw at it, the more usefulness that comes out of it. So that ties together most of what's currently in the system. And what we'll be looking at and adding is more modules. The example configurations, the sample templates that Bryce showed, it can be used for any tools. And once a new tool is there, the correlated data with the other sources, it changes everything. It's what you can pull together, what can be added. So we're excited to see if people have other use cases, if there's specific modules or specific tool sets that they would like to see included with these type of things. And that'll all be out there so people can test and do whatever they would like with that. Right now, a lot of the searches are all kind of single searches on how the app's being developed. Initially, when we were looking at it, we tried to fit it in with Splunk data models for the common information models. Unfortunately, there's not really attack data models right now, and you can't necessarily put a square into a circle. I tried to make it fit. This is something that I think will need to be created, and I have some test data models, but nothing that worked perfect. But in the future, it'll make it easier to onboard the data through the service within the data models just by tagging them correctly as far as those new data sources. With the current data, everything you're looking at now is just tied with all the pen test data. But for all of the people that raised their hands out here with other data within Splunk, they've used it. That means that they have their system logs, their network logs, file integrity monitoring, their host-based intrusion detection system, all in one place. When you start tying together blue team and red team logs for that correlated data, it makes the initial assessments easier for extracting the data, and it makes follow-up easier because the exact equivalent of those attacks are there, which is awesome. And the blue team guys will love it, management will love it, everybody will be happy. The trending is really tied into having more data. The more data you have, the more consistent it is coming in. Within the scheduled events, it's every 4 hours right now, but that can be increased to whatever you'd need it to be. And it can be used for extracting those problems as they happen, whether it's configuration problems when a new release is dumped or a new build is pushed out that caused problems that added pages. Those are caught up and you can alert on those. MLTK within Splunk is awesome. The machine learning toolkit looks at data, and there's a lot of teams who are already starting to use the machine learning for security in general. I think there's actually a couple of talks. There was a course yesterday that focused on it, and I know there's a lot of room for growth in this. So but you need a lot of very consistent data over periods of time. So as this gets added and improved, I really see it going the direction of MLTK. A lot of the custom commands within Splunk that you can use to manipulate outside sources, obviously it requires with APIs. So adding the API within the autopilot software is going to help us to kind of just increase what we can actually do with the systems. Anything else, Bryce?
Yeah, we just want to make it more usable in the future, and kind of yeah, there's some optimizations there too. So we're going to release the source code before Saturday. So if you want, we'll tweet out the links to the source code, so that'll be there available. We'll throw the slides up too, and we really appreciate you coming out to our talk today. If you have any questions, we're happy to answer questions. We feel like this is really going to help improve automation and testing and visualization inside of Splunk. So thanks everybody for coming out.
Definitely. Thank you.